Good morning. Hello again, Year 7. Here is your second lesson in common chemical reactions. And yes, there is a practical a little bit later on. So you will need to start this early this week. Now your starter is on this slide again. You've got two questions. The first one has got an arrow and the words products and reactants for you to put in the correct order. And below it, you've got a student's answer that has got some mistakes, so you need to correct it. I would suggest that you pause the video while you do these tasks. Okay, here are your answers. Remember, reactants go in front of the product. R-I-P. Bit grim, but it works. Here are my corrections. Your writing is probably neater. I don't find it very easy writing on a computer, but I thought I'd show you just what you have to do. Right, our objectives today look like loads, but that's because they fit in mainly with our practical. So we are going to know how to name the products of a reaction. Remember, the products are the things that are made in a reaction. We're going to carry out an investigation into iron oxide formation. Investigation, long word for practical. That is going to include making a prediction, identifying dependent, independent and control variables. We've done this before. The vocabulary is probably trickier than what we're actually doing. Draw a conclusion from a practical and suggest further investigations. Now, as I mentioned at the beginning, the practical takes about 5 to 7 days to work, so it'd be a good idea not to leave this to Sunday night to start. Right, first objective, naming products. If you have got two elements involved, the metal comes first. You can check that with your periodic table. That's one of the things we did last week. If there are no metals, the element closest to the bottom left comes first. And the last non-metal often changes its name so that it ends in "ide." So sulfur becomes sulfide, oxygen becomes oxide, chlorine becomes, you got it, chloride. You will want to write these rules down in your book, or make sure you have got them in your class notebook on Teams. If you copy the PowerPoint over, you will already have that there. You can add your own notes when it's in your own copy. If you want to do that, you'll need to pause the video now. Right, this is practice time, not practical time. So you've got a beautiful chemical flower. In the middle, we've got a metal, lithium. Around it, we have got 6 non-metals which it can bond with. And all we're going to do is write word equations. We're not going to do any symbols today, just practice words and that changing of the ending. So being very kind, I have done the first one for you. Lithium plus iodine becomes lithium iodide. Can you see the change at the ending there? IDE. That needs to be there for this to be correct. Your turn now. Write out the first one as a model. You don't need to see the change, that's to help you think. Then work your way around the flower. So you'll have lithium plus iodine is the second one. Lithium plus bromine is number 3. Number 4 is lithium and sulfur. Number 5, we're nearly there, lithium and oxygen. Last, lithium plus chlorine, because then we're back to the beginning. Sorry, I might have done this in wrong order. Lithium and fluorine. Got the numbers wrong, sorry. Doesn't matter which order you do them. You have got 6 to do. You will need to pause the video while you do this in your class notebook. So now it's time to find out about our practical. I'm going to suggest that you watch all the video the first time to see what you need to do. Then you re-watch it from this slide to set the practical up. That way you're not going to have any surprises and have to run away and get things that you haven't organised. Now we're looking at rusting today. This is a chemical reaction between iron, oxygen and water. The chemical name for rust is iron oxide. You've probably seen it as that red powdery stuff on some metals. It's not good because when it happens, the metal is degrading and the metal object becomes weaker. The chemical equation for it is iron plus oxygen plus water becomes iron oxide. That's a word equation, not ask you to write the symbols. Now we will need water for the reaction to occur, and that we will provide. Oxygen is in the air around us and we don't need to have a bottle of that. We're going to test how we can change the speed of rusting. Pretty exciting stuff, hey? Let's see what we need. Now, like any practical we do at school, you are going to need to get all your equipment together first. You'll need 5 steel nails. They need to be steel because steel contains iron. 5 containers. We could reuse some plastic pots, linking in to our plastics challenge, or we can use glass jars that are empty. Don't put it in a jar of jam, obviously. You're going to need some tap water. You're going to need to boil the kettle, let it cool, and get some cooled boiled water. When you boil water, it removes the oxygen that is in there. That sometimes makes the water that comes out of your tap look a little bit bubbly. You are going to need some salt and you are going to need some oil. You are going to need somewhere to keep your investigation because it has to be in place for 5 to 7 days. And you need to have a permission of an adult in your household to use all these things. Do not go helping yourself to nails or oil without checking, because Mum wants to cook the dinner, someone wants to cook dinner and we haven't got any oil. I will not be very popular. You will not be very popular. It's also important with an investigation that an adult knows what you are doing. Now, if you've copied this PowerPoint into your notebook, you're not going to need to write any of these off, but you might want to put a little tick when you've organised. Here comes the diagram. Now, this isn't the most amazing diagram because I have drawn it on the computer, but the white shape here is your plastic pot or your glass jar. If you get something that is transparent, that'll be really good because you can see what's happening without having to move anything about. You're going to put your nail in it like that. It'll need to touch on the bottom. If you get one that goes halfway up so it can be completely covered, that doesn't matter. If you get a tall one, that doesn't matter, providing that when it leans on the container it doesn't knock it over. We don't want a big mess anywhere. Now you're going to need lots of containers and you need to have the following things in them. First of all, we're just going to have a nail in the container on its own. That will show you what would happen if a nail is in a container. That is your control because you're not adding anything else in. Second one will be a nail in a container with tap water. Third one, a nail in a container surrounded with water. Fourth one, a nail in a container with some water that you've previously mixed some salt into. So that'll be a little bit like seawater. Please don't go tasting it. Remember, we don't taste anything in a practical. The last one is a little bit fiddly and you need to be careful not to knock this because you're going to have your nail, you're going to put some boiled water in, it's water from the kettle where it's lost the oxygen, and then you're going to put a thin layer of oil on top and that will stop any oxygen getting into the water. Now, you should have got this copied into your notebook. If not, I would freeze this slide while you set up your practical. Right, something we really like. You are going to need a results chart in your science workbook. Even if you have not copied the whole presentation over to make notes, you must have your results chart so that, because I can see your notebooks as well as you and I can see what you've done. That means you won't need to take a photograph and send it to me by email because it's a lot easier for everyone if your work stays in one place and I only have one place to have a little look. So you're numbering your containers, that's exactly the same as it was on the previous slide. What is inside them is the same as on the previous slide. I've made sure it matches. The third column here says rust after 1 week. If you run a bit short of time, you can do it in 5 days. You can't do it a lot faster than that. How much rust? You're going to give it a score out of 10. So the one that's got loads would get a 10 out of 10. If it's got none, it would get 0 out of 10. If it's got a little bit, not so much, you've got the idea. Notes, that is a space for anything that you want else that you notice that you want to write down. Show me what a super scientist you can be. I'll put some information into your class notebook on how to draw a table. It's just like the same as Word. So you're going to need 1, 2, 3, 4, 5 columns and 6 rows. That's the information you need to put into the insert table. Now pause it here if you need to do that. Now, at the same time we set this up, we're going to need to record the following information. The hypothesis, the idea we are testing. We had that right at the beginning. We are testing how we can change the rate of rusting. That's underneath it, or conditions affect how a steel nail will rust. We have to say it's steel because that's the type of nail we're using. Predictions. Make a prediction for each of your 5 jars, not just one prediction. So the nail that is just in a jar with air, no water, what do you think will happen? What about the nail that is in water? What about the nail that's in oil? It doesn't matter whether you get your predictions are right or wrong. It's the fact that you're thinking about the science and what could happen and saying what your ideas are. That's what scientists do. And sometimes they learn more when their prediction isn't inaccurate than when it is correct, because then that can give you more questions and more things to do. Now, the independent variable is what we are changing. The dependent variable is what we're going to measure. Control variables are things we're keeping the same. This needs to go in your team's notebook so I can see it too. These things, what we're measuring, what we're changing, what we keep the same, you can check all of that using a table. I've been really kind to you here. Okay, so that's the end. That is the end of the work on the first day. But don't stop the video now because there's more. How exciting. In between 5 and 7 days, you're going to need to check your nails that are in the jars, not the nails on your fingers, and complete the table. Now, you might have noticed something happening earlier on, and you could have put that in the notes. If you didn't, don't panic. Oh, sorry, quick, just spotted a typo there. Sorry about that. Right, you need to review when you've had a look at what has happened to various nails. You're going to need to have a look at your predictions. Were you correct with all of them, some of them, none of them? If you were correct, well done. How did you know this? If you were not correct, what have you learned? Review the variable, what affects the rate, that is the speed. Rate is a scientific word, of rusting. What is your conclusion? So what does it tell you about rusting and steel nails? How could we improve this practical? What would you change? What similar practicals could we do as a follow-up? In your team's science notebook for this information as well, please. Then you go to assignments. You mark handed in when it is complete in your notebook. There's a little box, you just click on it and puts a tick in. Then I can see that and I can fill in the box that says feedback and tell you what a fantastic job you have done. I think this is straightforward. If you've got any questions about it, please put your questions in posts on the 7.2 Carson science page, not in general posts, in the 7.2 Carson page, so that everybody from year 7 can see the questions. And then if lots of people have got the same question, I only need to answer it once. You will have other information as well about the fact you've got an assessment next week. Please do not stress about that. But again, questions in posts in 7.2 Carson if you have any. Stay safe, stay learning, enjoy your practical year 7. Bye for now.